All right. Hi, guys. I hope you are well and I hope you're good. This is another session with TS Tutoring, and today we're covering conservation of mechanical energy, right? So, here I wrote the definition that the total amount of mechanical energy remains constant in the absence of dissipative forces, right? So by dissipative forces, we mean friction and air resistance. So in the absence of those forces, then the total amount of the mechanical energy will remain constant. So what do we mean? We mean that the potential energy will be converted into kinetic energy. So remember, we know from our equation, right, of mechanical energy. Let's bring another paper. According to what we know, EM stands for mechanical energy, right? So the mechanical energy is the sum of potential energy plus kinetic energy, right? So in the absence of all the other forces, the potential energy will be converted to kinetic energy and vice versa, right? So if we break this down, we see that the energy or the mechanical energy, we know the potential energy or gravitational potential energy, we are given, we can get it by using this formula, mgh. M stands for the mass, g for gravity, h for the height, right? Plus the kinetic energy formula is half mass velocity squared, right? This is how we get the mechanical energy. But now, with the conservation of mechanical energy, we are saying that the initial mechanical energy, we can use I for initial, will be equals to the final, so F for final mechanical energy. And we know that the initial now will be mgh initial plus half mv squared initial will be equals to mgh final plus half mv squared final. This is the formula that we use for the conservation, right, of mechanical energy. When you say something is conserved, it means that it never runs out or it never reduces, right? It's constant. We are only converting from two things. It's either converting from potential energy to kinetic energy or kinetic energy to potential energy, right? So this is the formula that we will be working with, that we are going to use, right? So let's do one example to calculate mechanical energy, the conservation of mechanical energy, right? So what I want to emphasize first, let's deal with the potential energy, actually, the gravitational potential energy before we go further. So the gravitational potential energy, the formula is mgh, isn't it? You see, it depends mostly on the height, of course on the mass too, but on the height. So I want to emphasize that if there's no height, then the potential energy or gravitational potential energy will be equals to zero, right? So let's say, for example, an object, right? Let's say it's at the top of the building, right? And the height of the building, let's say it's 7 meter long, and then an object is here. Now, when that object is there, it from the ground, its height is 7 meters. And if the mass of the object, let's say, is 1 kg, now to get the potential energy or gravitational potential energy for this object, we will say that 1 kg multiplied by gravity of 9,8 multiplied by the height of 7 meters. You will get that the potential energy of that object, if we plug in on our calculator, we see that 1 multiplied by gravity 9,8 and the height of 7 meter, the potential energy that we get is 68,6 joules. Remember, energy must always be in joules. So we get 68,6 joules of potential energy. Once this ball falls, now let's say it's falling, right? Once it starts to fall and it reaches the ground here, there's no height, right? So how much is going to be our potential energy? Well, it's going to be the potential energy on the ground now is going to be mgh. The mass is still the same, doesn't change, 1 kg. Gravity 9,8. Well, the height is how much? 0. Anything multiplied by the height, you will see that is 0. Anything multiplied by 0, it's 0. So now the height is 0. Now the energy is 0 joules, right? 0 joules. You see what I mean? The potential energy depends on the height. Of course, if you increase the mass, the potential energy will also increase. But here, it depends on the height most of the time. And we are saying that at the top, the potential energy is maximum. At the bottom, the potential energy is minimum. There's no mechanical energy. There's no potential energy because there's no height here. So when height is 0, there's no potential energy. When height is 7, or when there's height, we get our potential energy, right? So let's bring in another paper. So now let's now explain kinetic energy. Well, the kinetic energy of an object, when we talk about kinetic energy, we talk about moving objects, isn't it? So the kinetic energy will be half mv squared. Now, usually, still the same ball at the top here. The ball, the height is still 7 meters. So the ball at the top has, you see, the kinetic energy depends on the velocity. So if there's no velocity, kinetic energy is 0. At the top, when the ball is at rest, just chilling there, the V here at the top will be equal to 0. Remember, the mass is 1 kg, isn't it? So let's calculate kinetic energy at the top. So at the top, our kinetic energy of the ball will be half mass velocity squared. So half, the mass is 1. Now the velocity is 0 because the ball is at rest. So once you see words like rest, know that the velocity is 0. And if the velocity is 0, anything multiplied by 0, we're gonna get 0 joules of kinetic energy. So at the top, kinetic energy is minimum. There's no kinetic energy. But once the ball starts to fall, as it falls, it's now gaining speed because gravity is pulling it down. Now when it gains speed, it then means that we're gonna have kinetic energy. Let's say that when it was here, this ball, when it falls down, let's say that the V was 2 meters per second, right? How much would be its kinetic energy here? Well, the kinetic energy there will be half, mass is 1, speed or velocity is 2 squared. Let's see. Now half times 1 mass, velocity 2 squared. We get 2 joules of energy. So now do you see, once we have the speed, we can get the kinetic energy. We have the kinetic energy. So now let's go back to so what we are saying is that at the top, always kinetic energy will be equal to 0. At the bottom, before the ball hits the ground, it needs to have speed. Therefore, kinetic energy must be maximum. So let's talk about conservation of mechanical energy. Now, let's use an example now to calculate use the conservation of mechanical energy. So let's say we have an object on a slide, right? The height of the slide, let's say, is 8 meters. The object is here, is at rest, you see it. Now, the question then says, calculate the speed of the ball at the bottom, right? What would be the speed of this ball, or the velocity, when the ball reaches here? Once it starts to fall, what's going to be its speed? Well, first of all, also, let's say that the mass of the ball, let's say, is 3 kg. It's on the slide that is 8 meters long, right? Calculate its speed at the bottom. So calculate velocity before it hits the ground. Right? So we are going to use the conservation, right? So of mechanical energy. We know at the top that because there's no speed here, it's just chilling, kinetic energy is 0. Remember the formula that we're using? So at the top, mgh plus, initial plus half mv squared initial will be equals to mgh final plus half mv squared final. We're looking for the vf, you understand? Therefore the v initial, because it's at the top, is resting is 0. Now let's calculate the potential energy. Well, at the top the potential energy must be maximum because there is height. The mass is 3, gravity is 9,8, and then the height is 8. Well, the initial kinetic energy is 0 because it's at the top, is at rest, no velocity. At the bottom there's no height, therefore potential energy is 0, but there is kinetic energy. The mass is 3 and we're looking for Vf, right? If we do our calculation, 3 multiplied by 9,8 times height of 8, our potential energy will be 235,2 at the top. So we have 235,2 joules at the top, which will be equals to, now half times 3, 0,5 multiplied by 3 will give us 1,5. So now we'll have 1,5 v squared, right? Vf squared. Now to get Vf squared, we can divide both sides by 1,5, right? 1,5 and 1,5 cancel. Now let me solve it here, right? I don't wanna go far. So Vf squared will be equals to 235,2 divided by 1,5. Right? So calculator, 235 divided by 1,5, or 235, what, 2, right? It gives us Vf squared of 156,8. Now to get Vf, we take the square root of both sides. Now Vf will be the square root of this answer. So the square root of answer, it's 12,5 meters per second. So by the time the ball rolls from here, before it reaches the bottom, it will be traveling with a speed of 12,5 meters per second. That's how we use conservation of mechanical energy. So thank you for watching. If you have any questions, please comment, and follow us on TikTok at TS Tutoring, YouTube subscribe TS Tutoring, Facebook TS Tutoring, and Twitter is TS Tutoring. Thank you for your time. Bye.